Hello, this is Dr. Stephen Jones. This is the first lecture on inventory control models. There's 3 of these because we're going to go through them relatively quickly, 3 lectures that is. And they seem complicated, but it's really not. The formulas that are used are not calculus at all. It's basically algebra. And they are theoretical, but they help you to do a better job in trying to maintain a certain level of inventory, understand your production and ordering methods, and do so in a way that keeps you from having too much or too little stock on hand for whatever it is that you need. So as we do an introduction here, basically one of the most expensive and probably most difficult to move assets that you have. One of the least liquid of your liquid assets is going to be inventory. And if you remember from your accounting, your current assets would include cash, receivables, as well as inventory. And inventory is most difficult for you to move because, unlike cash, which is already liquid, or receivables, which you can factor out and get some cash on, inventory pretty much needs to get sold to somebody at some point. So it's expensive for you, it carries your name, and it's not as liquid as some other materials are. And it comes in lots of different forms, as you see here: raw materials, work in process, finished goods, anything from just beginning to finished inventory will be on your shelves if you're doing the production format. And if you're not doing production, if you're like a retail organization, you're still going to have inventory that comes in and could be collecting dust on shelves until you actually get it moved out. So you need to be sure that you've got some level of good inventory for your customers, whether they're businesses, governments, or consumers, and yet you want to minimize any potential losses or insurance costs or just holding costs, because as long as you've got inventory on the shelf, it's cash that you can't move. It doesn't convert back liquid until it actually gets sold. So it's just assets that are being held, and if you can move it out quickly, that's all to the best. If you can keep lower inventory levels, overall you're going to keep insurance, shrinkage, loss, costs down, and that's all to the best. On the other hand, you definitely don't want to get stock out, and that's a problem with lower inventory levels as well. And so you have got to figure out some way to control the inventory, whatever it is that you choose to do. Now, if you're going to have a manufacturing process in this, you are trying to reduce your delays and improve your efficiencies at the same time as you are somehow keeping your inventories up. And while, at least theoretically, that you can have labor stored as a component of sub-assemblies, that is to some extent true. That's theoretically true. It just doesn't seem to be something that's valid on the face of it. However, materials you can easily see as raw materials, work in process, or finished goods. Labor could be something that you keep stored up on the side. And seasonal things will complicate this even more. And you'll see in a later lecture that quantity discounts complicate this even more as well. So how do we start taking a look at this? Well, we need to look at how regular your supply is. If you have an irregular supply and demand, again, say seasonal or periodic demand that's out there, you're going to have to account for that. Look for the quantity discounts when possible, but that's going to change your economic order quantity out there. And then how critical to you would stockouts or shortages be? If customers are willing to wait for product, then stockouts aren't as much of a problem for you. But if they're ready to walk out of your store or switch to a new supplier at a moment's notice, then you've definitely got to be on top of your game in case you were to have a stock out. So, how do you order? That is, how much do you order? And when do you order when you're talking about inventory? And we'll see the same thing applied to production in a shortened fashion in a later slide. But basically, when is it that you're going to order product, and how much do you order at any one time? We're going to look first at the how much to order, and then we'll look at when to order later in this chapter. So if you're going to lower your inventory cost, then whenever possible, you need to make sure that the cost of the items is as low as possible, ordering is as low as possible, carrying, holding inventory, like insurance, etc., and any cost of stockouts are going to get minimized as well. Ordering costs are independent of order quantity in that you have to pay these costs anyway. It's like shipping and handling costs or something along those lines. Essentially, it is what is the cost in your personnel's work, or in if the supplier company happens to say, for each order costs you $25 whenever you order, whatever it is. Those are costs that it doesn't matter if you're ordering 1,000, 2,000, 1,000,000, you've got to pay those costs somehow. Holding costs come at you in that you have a limitation in your space. There's only so much floor room that you have in your facility. Increased insurance costs, increased loss, either through shrinkage, somebody took it, or it got damaged, somebody ran into it with a forklift, somebody walked out with it, a rat ate it, whatever it is. You've got some costs in there for holding it just because it's there for you, but also because it's tying up your money, and that becomes a cost for you as well. As a result, we have the economic order quantity model, which is an attempt to try to get this to be some rational means of deciding how much do I want to order at any one time. Now, this is a theoretical model because sometimes you're going to find yourself having to order in lumps of quantities. In other words, you can't go into a store and order one hot dog bun. You got to buy a package of hot dog buns, and a package of hot dog buns might be 8 or 10, or it might be 20, or whatever it is. You got to order whatever it is in whatever combinations they have. So it's theoretical, and if you can order in individual items, that's what you should do. If not, you'll have to adjust what the EOQ says should be the amount that you do. The economic order quantity has some assumptions in here. One, it assumes that you know how much people are going to want and when they're going to want it. It assumes that you know how quickly you can get it. And these are not bad assumptions, but they're important assumptions, because if you don't know these things, then the EOQ is not going to function for you. If it also assumes that you can get the inventory as quickly as possible, and that whatever costs are out there, those costs are relatively constant. And again, later we will adjust for order quantity discounts. But essentially what it's saying is that if you order 1 or 1,000, it's all the same to you. And that may be an assumption that you have to adjust later on. And then you want to be sure that you also have just ordering costs, holding, and carrying costs out there, and that those are the same all year long. If that is not true, again, adjust for that in interpreting your results. If the insurance costs are going up, or if labor is going to be more expensive one part of the year versus another part of the year, or whatever, you'll need to adjust for that out there. Then you also want to be sure the EOQ tells you that you don't want to have any stockouts or shortages, that you're going to order soon enough and in large enough quantities so that you're not ever going to run out of inventory. And this is essentially what it's looking for, that you're going to try to deplete your inventory as much as possible and then order the amount that you want and get it all there essentially the same day. So, as a theory, again, this is a good decision model. Practicality, you simply need to adjust and understand that theoretically, this is not necessarily reality. You cannot assume here in this part that you are necessarily going to be able to get everything all at once. When we look at the production side, it's going to be an increase like this, where you're going to take it on a diagonal, because you can't produce everything in one day that you need and then burn it out over a 2-week period of time, or however long this is. So, if we were to look at this with numbers, and just throw some numbers in there, we're going to look at this with a table on inventory levels. This is where we see what our usage is. You'll notice start the day on April 1st with 10, you end the day with 8, and you have an average of 9. Why? Well, because for the EOQ, the average is that you add beginning and ending and divide by 2 and assume that that's the average out there. That's fine. That's, for these purposes, that's fine for this decision model. And you do this every day, and so you see at the very end, you've over a 5-day period of time used up 10 whatever widgets or whatever this is, and you're doing that at essentially a 2 items per day inventory usage. So your annual ordering cost is basically the number of orders that you put in there times the number, the number of orders times whatever the cost is. Your carrying cost is your average inventory times whatever the cost is for carrying stuff. And then you'll see how quickly we actually use all of this. In graphic form, it kind of looks like this. And I know this looks like those, economist models out there. Just understand that essentially the carrying cost curve here, the more you carry, the higher the cost is, because as the order quantity increases, the cost of carrying increases. Again, insurance, lost other opportunities, etc. Whatever it is that you're throwing into your carrying costs. As you carry more, then it costs you more. On the other hand, you would find the ordering cost curve goes down as a percent or as a per unit cost. Because if it costs you the same, no matter how many units you order at a time, then the more units that you order, the per unit ordering cost is going to go down like this. If it costs me $100 to order one item, then that's going to be my cost, $100 for that one item as a carrying cost, as an ordering cost. But if the cost to order, not the cost of the unit itself, but the cost to order is still $100, but I order 100 units, you'll notice it's down here. It's now $1 per unit on average. See, if I only order one item and it costs me $100 to order it plus the cost of the item, then that's an extra $100. If I order 100 of them, then that's $1 per unit, because still $100 to make the order. It's $100 divided by 100 units, which is $1 per unit as an ordering cost curve. Okay, so it goes down that way, and what you're looking at is essentially it crosses here, and that is also your lowest total cost for carrying and ordering together, and that is what you're trying to find out right here. Because whatever the cost of the inventory itself is, whatever a widget costs, $1 per or $16.3, whatever it is, that's not important. That's not relative in the basic EOQ model. That's going to happen whether you order 1 or 100 or 1,000 units. What you're trying to do is take those auxiliary costs and take them out of the equation as much as possible. And the only way to do that is to minimize ordering costs and carrying costs, and you do that right here. So while the inventory itself is not going to get any cheaper for you, the cost of having that inventory is minimized right here. And that's what this model is all about. Having the inventory, minimize the cost of that so that it's worth it for you to keep that into the system. You do that, well, you could do that with each of these equations here, but instead what we're going to do is look at the bottom equation, the economic order quantity right here. This is the equation, the only equation that you're actually going to be using. So your cost of ordering and the cost of holding or carrying cost are what's actually in play here. And so let's take a look at how it's done. Let's suppose your demand is 1,000 units. That's D. Your ordering cost is $10 an order. That's C sub O. Your holding cost or carrying cost is 50 cents a unit. That's C sub H. Put that in here. Do your calculations. 2 times 1,000 times 10 divided by 0.5. And then take the square root of that. And what you come up with is 200 units. You minimize the cost of ordering and carrying together at 200 units. After that, if you go any lower or any higher, the cost is going to go up either because the cost per unit to order or the cost per unit to carry are going to outweigh the reduction that you have. After that, then, take a look at what the total cost is. The total cost for this project then is the demand over quantity times the ordering costs plus the quantity over the average quantity, that's the quantity over 2, times the carrying costs. You put those two together to see how much 200 units is going to cost you throughout the year. And essentially it's going to be $100 to carry the costs, to carry the inventory throughout the season. And that's what it looks like graphically. So we've reduced our per unit ordering cost, we increase our per unit carrying cost, and we minimize the total cost of it right here at 200 units, which is $100 for the total cost for carrying and ordering together. And that's it for this part of the lecture. We'll see you at the next one.